Good afternoon. Yes, hello. Did you all refill your energy levels with some nice lunch? Yes, was it good? Yes, good. And there's more to come. But first, we have another round of presentations. And they're not just your regular types of presentations. No, these are much shorter. And they are our lightning talks. So, yeah, already the little child over there is very excited. I can hear it. And while it's very short, it should be very powerful, and we should just go all through it. So I will not make this too long. And get on to our first speaker of the lightning talks, which is Erik Hooijmeijer. Come join the stage. Give him a round of applause. Yes. Take the stage. Talking about mazes.
Don't panic. Okay, I love mazes since I was a kid. I used to draw elaborate designs on grid paper and then torment my parents, my sister, my friends with it, asking them to solve the maze with me, standing behind them, and counting each wrong turn they took as a victory. Later, it influenced my career choice. I studied electronics, mostly because PCBs, printed circuit boards, look like mazes. Yes, and now I am a software engineer. And I deal with business logic with maze-like complexities. So, as a software engineer, I love algorithms. And that means as well that I looked into maze generation algorithms, and I'd like to share 5 of them with you. And for the first one, we go back to the 80s, to the simplest maze generation algorithm I know, which is the humble Commodore 64. And the maze algorithm I like to show first is a one-liner. It's a classic one, and it just prints random back and forth slashes like this. And I think you can see where this is going. Just by printing random form backslashes, it produces something that resembles a maze. The question, though, is it a good maze? And I think the answer is no, because as you can see, there's some places in this maze where when you start, you can't go anywhere. You're isolated. And it means that this maze is not well connected, and generally, it's not going to work. This is not a perfect maze. A perfect maze means that you can get anywhere. So what kind of algorithms do we have to make perfect mazes? Well, the simplest one I know is by copying and pasting, and which is a fancy name for tessellation. So what you do with this first algorithm is you take the simplest maze possible, which is a single cell surrounded by walls, and then you copy them in X and Y direction, and then you break 3 of the 4 walls because you want to have a perfect maze which is well connected but has no loops. And there you have it. It's a banded corridor, but formally it's still a perfect maze. And now if you repeat this process, oh wow, and break the walls, and then you get, well, actually something that looks like a maze. It's pretty neat. So if you repeat this, oh, wow. Yeah, this is quite like, this is getting more complicated, but very repetitive. So it's not really a good maze at all. So let's have a look at another very simple algorithm, which is the binary tree algorithm. And it works on a grid of cells surrounded by walls with evaluating a single cell. And you can only break the walls up or left. Well, the first position is slightly awkward because there are no walls to break because you're in the top left corner. But the next one, it has only one choice. Yes, well, you can see where this is going. This is really boring. And now, oh well, it's still boring because it can only go up. This is where it gets interesting. It has 2 choices. Which one will it take? Oh, left. Left. Left? No, this is not good. Ah, up, fortunately. Oh, well, you can see where this is going. So let's finish the maze. And there you have it. It is a beautiful, perfect maze with a slight bias for left and up. Yes, not very good at all, actually. So we need more randomness. And that's why we have the random walk. And the random walk is exactly what it does. It randomly walks through the grid, breaking walls. However, because you want to have a perfect maze, you cannot just break every wall. No, you can only break the wall if the wall you break is leading to a cell you haven't visited before. And to show you, I will just step some bits randomly, and you can see that it goes to a new cell, and thus it breaks the wall. Oh, well, my mouse is... Oh, now it throws back and left, and yes, well, this is all very interesting. It's very random, and... Oh, did you see that? It went back to a previously visited location, and it didn't break the wall. That is pretty amazing. So the algorithm works. Now let's finish the maze. And this algorithm has one slight disadvantage if you're doing a lightning talk of 5 minutes only, because you don't know when it's going to finish. So I'm just going to break it now and move onwards to the next algorithm, which is also our last algorithm, which is a recursive algorithm. It works similarly, but with the difference that it backtracks. And so it picks a random direction and checks if the cell is visited before. If it's visited before, we can't go there. And it repeats that until if there is one direction you can go into, it will take it. If not, if there are no other locations to go to, it will just traverse back up the stack and backtrack until it finds a position. And when the top of the stack has been reached, the maze is finished. So let's see this in action. Pick a random direction, pick a random direction, random direction, random. This is going good. That is what we like. Now let's see if it can run itself. Now move left. Yes! And here, oh no, there are no further directions to pick. So now it will move up the stack and backtrack to a previous location where it has a choice to make. And here it can go right, so it will, and you can see how this is working. So let's finish the maze. And you can see how it backtracks and fills out the complete maze with very much efficiency until it reaches the top of the stack. And that's it. We have a perfect maze with a slight bias for long corridors. And this is just the beginning. I show you 5 maze algorithms. There are many, many more. There's a fashionably old-school website on astrolog.org which lists many of these algorithms. And there's this really cool book I bought some time ago, which is Mazes for Programmers. It's from 2015. I just love it. And with that, thank you.
Thank you, Erik. Very nice. Sometimes seeing how that thing walked, making mazes, I thought of my own life. Which direction will I take? Oh, I don't know. So, going into a more extreme kind of topic, I believe we have here Peter Hilton going to talk about extreme product development. I've never heard of it before, but when I read it, it was like, does it work that way? So you tell him. You tell him. Give him a round of applause.
Hi, so indeed, I just made it up. I mean, extreme product development is new. You're going to hear about it today for the first time. Now, it's not extreme sports. That's something else. That's when you're sporty in midair, I think. It's also not extreme ironing, which is a whole other thing. I don't know what's going on there either. No, my inspiration for this is unsurprisingly extreme programming. Now, extreme programming was extreme 25 years ago. People, especially manager types, got very upset by pair programming, and a lot of the other practices, really annoyed people. But it's not extreme anymore. It won. like it's mainstream. So I wondered, what is extreme now? What are the new practices? So I'm going to introduce some extreme product development practices. I'm not going to explain them all or tell you how to do them because I've only got 4 minutes and 5 seconds left. What I'm going to do is tell you that they exist and that I've done them, and your excuse for not doing them is that they're hard, not that they're not possible. So, for example, I've been working for remote-first companies for a while now, 2 companies. They started remote first, which is probably important. So we're talking about startups, but we work from home. We don't go to the office. This is really a thing. It works. What have I learned from it, though? Surprisingly, it turns out that working remote is really good at filtering out the assholes. I like that. I also work part-time. I've worked part-time for the last 10 years, I guess, and part-time is great. It's more inclusive, but it's really a happiness issue because there's more to life than just your job. And happiness is important. So, I did write code for many years, but now I work as a product manager. And it turns out I still care about the joy of coding because I don't want to work with unhappy developers. So I care about the happiness issues. Now, working part-time, it's a privilege. I've learned that I'm privileged here, that I can afford to do it. I was able to translate pay rises into fewer hours because the money was enough. It turns out that both of these depend on asynchronous working, working more online, less in person, obviously. So these are dependency hours. And that's important. You'll see more of those. Now, working async, that means more thinking, more writing. It means less showing off in meetings, which, to be fair, I did kind of enjoy, but it wasn't really the right way to work. So it's more thoughtful, and that makes it more inclusive, and that's a good thing. I also learned, you need to be good at communicating in chat, honestly. Now, I also learned to work with a short backlog. That's when you have fewer than 10 not started tasks. This radically simplifies product development. It's not waterfall, there's no Jira. I learned from this that this just makes everything simpler. That's really nice. But to achieve this, you need some kind of structure. So objectives and key results gave me that ability to work in that less detailed way. OKRs, they're kind of tricky, but that really worked for me. It allowed me to work without asking the developers for estimates, but still have a plan. But to do that, I needed to be available as a product manager. So that means I need to be able to answer developers' questions in minutes, maybe interrupt my meeting. So doing this means that I respond to everything on Slack. Reaction emojis are a superpower. I need to be approachable. I need to be available. Short backlog also makes it possible to have a zero bug policy. Now, I got shouted at once by a manager for even talking about a zero bug policy. So that is definitely extreme. But it's really great when you do this. But you do need team programming because the last bugs are hard to fix. Team programming, it's pair programming dialed up to 11. Now, it turns out all of these depend on psychological safety. So unlike XP, which depended on technical practices, it was the psychological safety the whole time. That's what they are all dependent on. This is the thing you need to be building. If you think it's interesting to mend people, that's what you need. It all depends on psychological safety, and it mends culture as well. So as Duke said, people are amazing in their creativity when they realize they have the power to change things, that they won't be humiliated for speaking up. So that was psychological safety is the basis of everything. There's more from me online. Come and ask me all of your questions this afternoon. But above all, start talking to each other about psychological safety. And be happy. Thank you.
Thank you very much. Just by listening to this, I already feel like I had a whole workout for the whole day. Thank you. So now we're on to using our brains a lot because we need to learn. I read here because Ties van de Ven is going to teach us some things. I'm not sure yet what. Because he thinks that sharing knowledge is a very good way to grow in all kinds of ways. And you're there. Ah! I have not seen you yet. So, cool. Take the stage. Yes. Give him an applause.
Yeah, come on.
Good.
So it was June 2014. I was sitting behind a desk in quite a busy hallway, and out of the corner of my eye, I see my team lead walking straight towards me, looking very, very frustrated. So I'm already a bit like, what's going to happen? So the moment he arrived at my desk, he immediately went, "Thies, I can't believe what just happened. I just came out of a meeting, and this team said they could write software. And I just talked to, so the company said, okay, great, you can build the next business application. I just talked to the team, and by writing software, they meant they wrote an Android app once. I just thought, basically, they have no clue about software development. They ask me to help. I don't have time and energy to deal with this. Thies, you deal with this." Quite overwhelmed, because this was literally 2 months within my first, 2 months in my first job as a software consultant. And now I had to help a team start up a whole new project, something I never did before. So it's free to say, imposter syndrome really kicked in there. But I didn't really have a choice, so I had to do it. So I went to the team, gave them a few pointers, and basically told them, if you have any questions, feel free to ask them. So the very next day, they were like, "Thies, could you explain something to us?" And sure, what would you like to know? "How do getters and setters work again?" So, on one hand, I was quite frustrated, because how could the company let a team that didn't know what getters and setters were build an application? But on the other hand, that was a question I could answer. So, over the next few weeks, they kept on asking questions like that. And I started to realize, when I was starting as an engineer, I had exactly the same questions. But apparently, these days, I could quite easily answer those. I've grown in all that time. And that gave me the confidence to actually join their team and help them build this product. Of course, the questions became more difficult later on. I can still remember them at some point asking, "So, what's a singleton?" So I explained the singleton pattern, but then they asked, "So why would you use that?" Why would you use the singleton pattern? I never really thought about that before. I basically just used it for years, but never consciously thought about why should you use such a thing. So questions like these really helped me in developing abstract thinking, because I never wanted to answer just because. I always wanted to give a good answer. Quite some time later, about half a year, the project was finished, or at least my time at the project was finished, because I'm a consultant. And I was actually quite proud of what we achieved, since we went from basically nothing to quite a successful project. But most importantly, we went from a team that didn't know what getters and setters were, to a team where I could have quite high-level architecture discussions with, because these were very intelligent people. Everything I explained, they immediately picked up and incorporated into their way of working. And it was just such a massive joy to watch them grow as software engineers. So during my next assignment, I thought, I want this joyous feeling again. So I rounded up the juniors again and started sharing knowledge. But then I noticed something was different about myself. Because that imposter syndrome I had, well, it was still there, but it was noticeably less. By explaining all these things to the juniors, I got a bit more confident in my current understanding of things. And that gave me the courage to start speaking at internal knowledge sessions for that company. And it still took me quite a few years before I got up the courage to do international conference speaking, through teaching, coaching, and even doing some volunteer work. But now, here I am today, talking at international conferences for audience like this, mostly about software engineering fundamentals, which is a passion I developed from answering these kinds of questions, like, why would you ever use a singleton? And all of this because of sharing knowledge. And that's why I truly think that knowledge is the only thing that increases as you give it away. By helping others, I helped develop some skills for myself, which has been invaluable for my career up until this point. And if you're now enthusiastic about teaching others as well, if you want to do this as well, round up your juniors. And if you want to do more, There are some links there where you can volunteer to help teach children. There's a link where you can help volunteer to teach adults. And if you want to talk more about teaching, coaching, software engineering fundamentals, or need a coach yourself, feel free to add me on LinkedIn and send me a message. Thank you for your attention.
Yes, and thank you for sharing the knowledge. So we're on to a known presenter, because she already has presented here, but not as a lightning talk speaker, but one that would take some more minutes. But this time you only have 5. I'm gonna watch you. Yeah, okay. So come on the stage, Felienne Hermans. Give her a round of applause. And she will be talking about feminism in programming language design. Yes.
Hello, everyone. I am Felienne, and I made a programming language. Maybe you heard of it. It's called Hidde, hidde.org. And if you haven't heard of it, it's basically a simple Python for programming education. And when I created Hidde in 2020, I was like, where do I share this? Do I share this in a programming languages conference, or do I share this in an education conference? And I wasn't really sure, like, where does this fit? And ultimately, I ended up going to a programming education conference, and I had a lot of fun there, and everything was great. The end. No, because I actually did more work. I made Hidde also a multilingual programming language that I talked about 2 years ago at Joy of Coding. And that was a lot of deep technical work. And it was not so related anymore to programming education, because we can also localize professional languages. So I ended up last year going to a programming languages conference and talking about my work in localization. But then when I went there, I didn't really have a good time. I didn't feel at home. I didn't have fun. And then when I came home, I thought, hey, I have a case of the feelings. Help, I have feelings. What do I do now? Well, I'm a scientist, so if I have feelings, I will find some science to help me understand my feelings. But I'm a computer scientist, so I didn't really know what to do. Like, how do I study feelings? Well, I found the answer in feminism. And I was really surprised myself as well. I was like, feminism? I thought feminism is about individual liberties of women, like baas in eigen buik and fighting for maternity leave, having women in technology groups. I thought that was feminism. And that doesn't have so much to do with my feelings of not feeling at home. But this actually is a specific type of feminism called liberal feminism. And I know, though, that there's so much more in feminism. There's also, for example, feminist epistemology, the knowledge of knowledge, that studies what knowledge do we care about and whose knowledge do we care about. And in this tradition, I read a paper called Glaciers, Gender and Science. And when I read this, I was like, what does feminism have to do with the science of glaciers, right? This makes no sense. But there's one point in this paper about glaciers that explains that there's 2 types of glaciers. Glaciers in rural areas, close to where people live, but there's also glaciers high on mountains that are hard to reach. And you might think that the rural glaciers are more studied, but the reverse is true. People study remote and high glaciers because status is to be gained from climbing a hard mountain. Whereas just going to a glacier where everyone can go, that's not exciting. And so I thought of like, okay, so hard is valuable and easy is not. And then reading this paper has taught me more about the programming languages community than existing in the programming language community for 2 decades. It's like, I get it. Now I see, right? We value hard things like Haskell and C++ and proof assistance. That's cool because it's hard. Whereas things that we think is easy, like PHP or JavaScript or spreadsheets, right? That doesn't have value. And finally, I also understood the pushback I received to my work. Because taking something that's hard, like Python, for kids and making it easier, I had always understood making something easier is inherently good. I didn't understand that there could be a mental framework in which easier is not better. But in this mental framework, making something easier is taking away value. Like, right? I get it. And just looping that back to the current state of technology, we have all of these initiatives like, oh, we need more women in technology. We keep hearing that. But then what happens is we pipeline those women into a culture. And not into a culture where making things easier that we might also care about is actually great. You know, we go into this culture of people that are like, build stuff that is hard, this is what we like. And then, unsurprisingly, this is not really the culture where many people thrive. Not just women, also men that care about building stuff that's accessible. So women drop out. Or women are turned into people that also care about the hard stuff. And I also felt this was what was happening to me when I was at that conference. People would ask me, but Felienne, why is localizing a programming language hard? And I would say, well, it's really hard because, you know, you have like right to left stuff and accents and gender. I was buying into this framework of explaining why it was hard. Whereas when I was home, I was like, wait a minute, I don't care if it's hard. I care if it has impact. I don't share your value system. So if you want to know more about, I actually wrote a 17-page scientific paper about feminism in programming language design, of which you can read a draft on my website. Thank you.
Yes, very nice. And I'm sometimes wondering, Felienne, do you draw your own presentations?
Yes, by hand. It's a guaranteed LLM-free slides.
Oh, that's amazing. Yes. Well, again, round of applause. Yes. So, Joep, you're already here. Good, good. Yeah. Before the applause, let me introduce your topic. It's already huge on the screen, but nevertheless, Luddism, LLMs. Let me explain that. It's large language models. And you. Yeah, that's it. So give him a round of applause. Yeah.
That's indeed exactly it. Luddism, LLMs, and you. So the structure of this talk is Luddism, LLMs, and you. Quick disclaimer first, though. These are all my own personal opinions. So let's first talk about Luddism. Who were these Luddites? Well, they were textile workers in northern England. Their activity peaked 1811, 1813, and they were frame breakers. They broke stocking frames and power looms and all the machines used to industrialize textile working in northern England. And they were called the Luddites because they had this leader, but he didn't really exist. There was a story about the Ned Ludd person, but that's it. Because there were many very secretive groups, but through Ned Ludd, they had this banner to unite around this fictional character, also known as King Ludd and General Ludd. And the reason these people start breaking frames is they were used to working in something called cottage industry. And the work was demanding, and everyone was chipping in. But it was 30 hours a week on their own schedule with long weekends. So they did better than most of us do now, actually. And that got changed to factory working. Longer hours, someone else's schedule, you were paid less, and also quality of the products went down. So as artisans, they were rightfully upset about that. But not just that, because once you have machines to do the work, you don't need someone who completed a 7-year apprenticeship. You can hire children. You can get them from orphanages. You can get a 6-year-old to work 14 hours a day, 6 days a week. And then, of course, these people who had done the apprenticeships, they were out of a job because they were replaced by children. And then there was also, even then, some awareness of the whole environmental cost, about burning all that coal to make the steam engines run. And the funniest thing I discovered is I found the original tech bro. Edmund Cartwright had not a clue about how weaving works and thought surely it can be mechanized. And his first attempt sucked, but eventually he succeeded. He's the actual inventor of the power loom. So what was the role of the government in all of this? Well, not as good or positive as you might hope. The Luddites petitioned Parliament. There's rules and regulations. The factory owners are violating these. Police enforce them. And Parliament was like, nah, profit, progress, we're not going to do that. Instead, in 1788, they made frame breaking punishable by an exile of 10 to 15 years. And that didn't help enough, so in 1812, it became a capital offense and people were executed for it. And they also had to deploy the army domestically. 35,000 troops, that's like General Wellington level numbers of troops they were deploying to just get the Luddites in check. And it didn't end that well for the Luddites, unfortunately. There was this mass trial at York where they executed 14 people at the same time, 3 the week before. The only positive part is they did delay industrialization a little bit, getting somewhat better conditions, and, well, their legacy still lives on to some degree because I'm talking about them today. So to wrap up, to summarize, what they did was collective bargaining by riot, because that was the only option that was left to them. And they were in favor of tech and progress, but in a sustainable way, and had proposals to do that, but those were ignored. So the thing they were really protesting was extractive capitalism, to which I say, fair point. Then LLMs. What does it do with LLMs? Well, it's the same story all over again. LLMs harm people, the people working on the training data, the people who get pressured into worse jobs because an LLM is going to replace you, the people at the receiving end of all the slop LLMs produce. They're trained on stolen data, no one cares, this is fine, move on. They harm the environment, water, electricity, all the hardware. And that makes me think, are they that good, or are they tools to sell cloud services, GPUs, and keep the stock prices high? Because if there's a gold rush, you want to be the person selling the shovels, not mining the gold. So what does it have to do with you? Well, first of all, LLMs are not going to replace you. Capitalists are going to replace you with LLMs or something else to increase profit. And the only question is, what's it going to cost to us all? And then, on the other hand, I don't want to stand here all and be all moralizing and tell you it's a failing to use an LLM, so I did the next best thing. And I got you stickers, so if you want to rage against a machine learning sticker, come and find me. The link is for the person who actually designed those, by the way. It's not my, no credit to me there. And if you want to learn more, these are 2 great books. The right one is thinner, and Breaking Things at Work is great to read at work during your lunch break, just to freak people out a bit. Thank you. That's all I have.
Thank you very much, and I would love to have a sticker from you. Yes.
Noted.
Good. So, on to the next one, and Hidde de Vries, already here on stage with me, you are going to talk about accessibility, and I think in particular for websites, if I'm correctly.
Yeah.
So go ahead, take the stage, and give him a round of applause.
Thanks. Yeah, I should have called this web accessibility should be built into more software. I want to try and use the next few minutes to convince you not only that we should try and build accessibility into software, but also to be very wary when we end up in a project where that's the goal, to be very careful of what that actually means. Because it's not a one-off thing that we can do and then walk away. It's nuanced, and we've got to be careful with it. Now this month, actually last month, it was 25 years ago since the Web Content Accessibility Guidelines were released at the W3C. It's a document that they wrote to try and help developers to make more accessible web pages. It explains kind of what to do, and it's been really successful at that. The glass is kind of half full, half empty here. So on the one hand, this Web Content Accessibility Guidelines, the WCAG, they're in laws worldwide. Everyone is applying them now, or they're forced to apply them by law. Lots of litigation, lots of things are happening there. On the other hand, there's still lots of inaccessible websites. There's still websites with sticky elements that cover stuff, so when you zoom in, you can't actually read the content if you're a user that zooms in, and those users will come to your website one day. It's still inaccessible to people who are using just a keyboard. So there's lots of websites out there where you can access some of this stuff, but then like when you want to try and open FAQs or something, you can't see them or you can't get to them, you can't open them. So we need better websites, and the point I wanted to make here is that accessibility is a website problem. It's not a user problem. It's not their fault that they come to your website. We've got to fix websites, but I also think we can try and find opportunities to build accessibility into systems to somewhat make it easier to do accessibility, to make our websites accessible. And I realize now that's a feminist stance somehow. We want to make it easier. We can find opportunities basically to build accessibility into systems. Like CMSs, I don't know if anyone remembers this guy, or if I'm just showing my age. It's a sticky thing that showed up in Microsoft Word called Clippy. But like an assistant, it would try and help you make your documents better. I want to see this in CMSs. I want to see CMSs that are like accessibility assistants, because there's a lot of stuff that we can find in web pages. We can see that they are inaccessible and tell users about them when they have low color contrast, or when they're trying to create a list by adding a dash in front of each item. Tell them that's not a list. You need to use the list thing. We can also build accessibility into web platform features. I can't go into a whole lot of detail here, but most recently, web browsers introduced this new feature called the Popover API. In that API, what we try to do is put accessibility semantics inside of that. There's a whole blog post about it. I'll share that afterwards as well. It's on my blog, you can read it. But the point is that there's a bunch of things that we're able to build in. There's a bunch of other things that developers still need to do when they use this API. And that's how it works most of the time. When you're trying to build accessibility into systems, you get to build some of it in. And then the people who are then continuing with that work will still need to do some of the work themselves. It's never done. It's an ever-going thing that you need to work on. I also think we can put accessibility into user agents, making them agents for the user. So if web designers decide to have a UI that has low contrast, a browser could recognize that and increase the contrast of the colors on behalf of the user. Not respecting the wishes of the designer, but respecting the wishes of the user. And the same goes for focus indication and a whole lot of other things where websites are kind of falling behind or are inaccessible. We can have a browser that fixes that on behalf of the user. And then lastly, we could also build accessibility into design systems. So a project I work on at the moment is called NL Design System. We're at the Dutch government trying to get design system teams to work together. And one of the things that we do is that we put our design decisions into tokens, design tokens. And what that allows us to do is to also automatically find out about potential accessibility problems. So if there's two colors that we know are going to be used for a button, we can see that they don't have sufficient contrast together and warn the user about that. Or we can see that the target size of a button is not big enough, so we can't use it with our thumbs, that sort of thing. So built-in accessibility, I want to tell you today, it's not trivial. It's not a one-off thing that you can do or a quick fix, but it can be done, and it is worthwhile. Thanks very much. I'm HDV in most places, and you can find my slides online.
Thank you for sharing that with us. I think it's a very important aspect. We take that into account to make sure everyone is able to read pages and understand what's there. We have a new speaker on this stage, Karl van Heijster.
Yep.
I never knew that software development could be associated with flossing your teeth. But apparently it can, because you say, quote, testing code is like flossing teeth. Most people don't do it, and when they do it at the wrong time. So you tell him. Yeah?
Thank you.
Good. Give him a round of applause.
Thank you. Hi, Rotterdam. Good afternoon. I have a note on dental hygiene for you. I have it with me, but you kind of spoiled the surprise here. Unit testing your code is like flossing your teeth. Too many people don't do it, and those that do often do it at the wrong time. That note contains two very important messages. The first one is you should floss your teeth. You should do it like depicted here. You should create a C shape, hug your tooth, and then move that floss up and down, and that moves the stuff here and here in between your teeth, the stuff that's often difficult to reach with a toothbrush. Likewise, you should test your code. You should write unit tests for all the code you write. Why would you do that? You do that to find bugs. Where are those bugs? They are right here. often at the edges of your system or the edge cases in your system, stuff that's pretty difficult to reach by hand most of the time. Now, this is all pretty trivial stuff. I hope that we can all agree that we should test our code. There is a much more interesting message in the note I just read, and that regards when should you floss or test. You should floss before you brush your teeth. Flossing does the heavy lifting. Brushing your teeth is like the finishing touch. If you floss first, then it removes the stuff in between your teeth, and then the fluoride in your toothpaste can actually reach the places in between your teeth. That is why you should floss first. Likewise, you should test before you code. You should do test-driven development. Test-driven development is a mini workflow for coding. It has the following structure. First, you write a test. That test fails. Then you write the simplest, stupidest code you possibly can to make that test pass, and then you clean up the mess that you made doing that. You should do that, and then you should do that again, and then you should do that again. And this gives you several benefits. The first one is it will create a testing suite that you will trust your life with, basically. If all the tests pass, then you know you can ship to production. Secondly, this is a great way of breaking down a big problem into small chunks, one test at a time, which reduces cognitive load and makes you a happier developer. And thirdly, this will improve the design of your code. You will write testable code by definition, but also it gives you immediate feedback on the quality of your design. If your tests are hard to write, that indicates you have a design problem. These are all great reasons to do test-driven development, but there is a fourth reason, and that is that it will bring you joy. There is a certain specific joy seeing these red tests go to green and seeing more and more green tests over time. So TDD will bring a smile to your face. And now that you know how to floss properly, that smile surely is going to brighten up the world all around you. TDD gives you, how am I going to say this? How long do I have? I have a minute and a half. You should floss before you brush. And you should test before you code. That way, you will create the clean code to match your clean teeth. That was it. Thank you very much.
Wow. So after this one, flossing will never be the same for me anymore. And to be honest, I am guilty of first brushing my teeth and then flossing. I'm sorry. From now on, I will turn that around. Enough arguments have been given. So, the last speaker of our lightning talks, Quincy van der Sluis.
Thank you.
You are going to talk about gamification in AR.
Yes.
So, yeah, I do not necessarily know what gamification is, but feel free to explain it to me in your lightning talk. Give him a round of applause. Yes, yes. Take the stage.
Thank you. Good afternoon, everyone. My name is Quincy, and I'm going to show you 5 prototypes I've worked on last year for my graduation project at the Rotterdam University of Applied Sciences. And the topic was about gamification in AR. Now I would like to ask whoever has worked on an augmented reality product or project. I see a couple of hands, but I would love to see more of you work on AR as well, and I'm going to convince you all to work on it. So here we go. AR. AR is like AR 3D models in a real-life environment using your phone, for example, that will transform this empty field in Utrecht in a museum to a more immersive experience with 3D objects, a virtual guide, videos to really bring you to that moment of the historic event. And also in Rotterdam, I've made an AR tour where there are different spots in Rotterdam where you can go, scan the environment with your phone, and then new information will provide for you. And the question I was answering for my graduation project was how gamification can be applied and stimulate to do more of these tours. Because I believe that introducing gamification in these areas will make people happy and do them more and have a good time. So I researched, I talked to experts, interviewed them, I did brainstorming sessions with creative people, I did some sketching on how I would like to add puzzle elements to those AR tours, and did some coding, lots of coding, and tested these prototypes that I've built on with people and see what worked and what didn't work. And I've created 5 prototypes, and I'm going to show you to them. The first one is a AR maze. So it's a maze that you can create and you can walk through. You can collect hidden collectibles like coins to eventually reach that end goal of the tower. Really cool to just like create this environment where you can walk through with your phone like that. The second prototype I've worked on is some kind of like optical illusion. I really like puzzles. I've also loved puzzles, just like Erik talked about with the mazes. And in this one, you see random objects floating in the air, and your job is to find the perspective to match those objects and have a satisfying moment of like, yeah, I've done it, nice. And you can also add this to like letters, and that will spell a word if you find the right perspective. Really nice prototype I worked on, which I liked. A smaller one is a very simple one, but a very useful one. It's a moving object that goes from one place to another that could help people find the next spot in your tour. So in this case, there's a train at the Maritime Museum, and you can follow the train on its way. First, before I go to the fourth, this is some behind the scenes. I've used Unity engine to make a rubber duck now follow a square or a cube, and it worked fine. For the fourth prototype, also a very simple one, but very impactful one. This one is just a simple quiz question that you can find in the environment, in Rotterdam in this case, but I use the physical environment to make those people answer the question. For example, how many statues can you find on this building? There is a building in Rotterdam, het Witte Huis, and there are monuments on them with text, and this is the question, how many can you find, or what does the text say? So it motivates people to go there. And for my final and last prototype, I made a 3D AR puzzle that you have to solve in the environment yourself. So you have to rotate, you have to use perspective. And the first iteration is very simple. You have a red and a blue cube, 2 puzzle pieces, combine them together, and bam, you have a final product. Second iteration is replacing those cubes into real 2D sides of the puzzle piece. And when you connect them, then it will make a satisfying reward. As a particle system. And now I've changed from the 2D environment to a 3D environment. So this is real AR, and I'm testing this with users to see if they can figure out how to use the controls. And the fourth iteration, I've talked to my people around, and there needs to be more of a reward. So instead of only particle effect, you can also learn more information about the statue in this case. A reward system. So I've made the prototype, I put myself in front of a green screen, I recorded myself, I put myself in the AR tour and told more information about it, used PNGs or 3D models to make it all very immersive experience, and added that puzzle as well in the tour, which is super cool because it's physically also in front of the real statue, so you can also use it as an example. And I tested the tour with locals and see if it worked, and it was awesome. And then I celebrated it. I celebrated it with people as an event, and it was very nicely received. So yeah, that's my talk. Thank you very much for listening. My name is Quincy.